Okay, greetings. So continuing from our last video, we're going to be looking at some objectives today. So our objectives are going to be the between statements, the is null statements, is null, and joins. So now this joins is going to comprise of inner join, inner, left, right, full, outer join. So it's going to comprise of these three. So now this joint is a very large topic, so I would have to cover it in-depthly. So for this, we're going to create two tables. We're going to create two tables. So the first table, I'll call it create table first T. Yeah, creating first T, and inside this table, I'm going to give it a serial number, serial. I'll give it a name, character varying unlimited values, give it a course, character varying as well, and I'll give it a score. So I've not really used integers, so we're going to use that now. And I would create another table as well. I'll call it second T. I will show you something that's come in handy. We'll have serial number also. Serial number, we have name also, we have subjects, and then we have I just call it result integer, or we just use floating points. So floating points, so that in case because we know that from our introduction of data types, we know that floating points allow us to get decimal values. So just in case these students' results have decimal values in them, so that's why we are doing this. Alright, so now this semicolon that I've been using, you can decide to leave it out and your query would still run. But the reason why I'm going to use it here in this case, so the only time it becomes very important is if you are trying to execute multiple queries at the same time. So SQL uses this semicolon to specify that you are done writing a query, so that it can move on to the next query to execute it. So if I didn't put this here, for example, and I decided to highlight the both of them, SQL would think that the first query I wrote is part of the second query, so you would get an error because you cannot have two create table statements in one query. So a query is just a collection of code, just a collection of code that we write so that we can get them executed by our server. So in order for me to run these two queries together, I would have to put a semicolon to separate the both of them. So after that, you can decide to highlight the both of them together and you get your result. So it's going to execute the two tables. So it has created them successfully. Now, what I want to do I want to insert values into the both of them. So you say insert into first T. You can have your serial. Okay, so we're not inserting into serial number. Serial number generates by itself automatically. You have score, values. You can have James. You can have physics. You can have 86. You can have Alex. You can have biology. You can have 84. You can have Adam. You can have mathematics. You can have 88. You can have Gregory. You can have chemistry. You can have 82. And you put a semicolon. So I also want to insert everything together at the same time. I want to separate them with a semicolon to second T. And you can also have the next thing. Have name, you have your subjects, you have your results, and you have your values. Then after inserting your values, James, let me insert another value. Thomas Baldwin. Oh, sorry, alright, so this would be engineering. This would be 91. This would be Anthony. This would be chemistry, 90. This would be Richard. This would be literature. This would be their score, 85. Last one would be Mark, law, 92. Alright, so I can also decide to highlight everything together and execute them. We get successfully inserted into them. Alright, so now the first objective is to look at the between statement. So before I look at the between statement, let us see how our tables look like. You come here, you see select asterisk from first T. So you run that, discover that you have your table printed out to you. And we have our table printed out to us. Alright, so now what if I'm trying to get students that scored between 90 and 92? How would I do that? Of course, we can see that nobody scored that. What if we're trying to find students that scored between 85 and 86? How are we going to do that? Or rather, I scored between 85 and 89. How are we going to do that? So you just come here, I can just say select everything from first, and you now come here and see where score between 84 and 89. So now this would allow us to get students that scored between these two ranges. So the between statement allows us, so the between statement is used together with the where clause for extracting values based on a particular condition, and the between allows us to extract a value or a list of values that fall within a specified range. So the between allows us to extract values or a list of values that fall within a specified range. So this would extract rows. Like I said, I'm selecting everything. That select asterisk from first, whereby score is between 84 and 89. So this will allow me to extract people or students from this table that scored between this range. So we're going to have 84, 86, and 88 printed out because they all lie within that range except for the last one. If you highlight it, you will discover that you have just that. So the last row is going to be removed and we have 86, 84, 88. So that's how you can use the between statement. You can apply the not statement as well. You can say not between. So now this would allow us to extract values that don't fall between these criteria. So let us run our table again. Let's see what's up. So we get our original table. Now if I want to extract students that didn't score between these ranges, this will only print out the last row for us because it's only Gregory that didn't have that score. So Gregory had a score of 82 and he offered a course of chemistry. So if you highlight that and you click on play, this would only bring out just that row alone. Gregory chemistry 82. Right. So that's for between. So you want to come back here and asterisk it out. So you asterisk it. And the next one is null. Is null. I'll just create a small table. I'll call it null table so that we can be able to explain it properly. So null. So what does null simply mean? So null is used to specify that a cell in a table doesn't have any value. So null is used to specify that a cell in a table doesn't have any value. So I'll say create table null table. We want to create a table called null table. So this table will not have much detail. Just be very straightforward and precise so that we don't waste time. So I'll give it a serial and can give it a column. I'll just say name, character variant. Now I will insert values into it so that we won't waste time. So insert into null table, and you can specify the only value that it has, the only column rather that you are allowed to insert values into. And just say Alex James. So now the last cell will have null. So what this simply means is that this cell doesn't have any values in it. You can highlight everything with the create table. So like I said, when we are trying to execute multiple queries at the same time, this semicolon comes in handy. It becomes very, very special and very important. You highlight it together and then you can run. It has successfully inserted it. So you can select your table, select everything from null table. So you can see that now the last column has a null value in it. Last column has a null value in it. All right. So now you can see that this means that it doesn't have any value. So let's say we're trying to extract that particular value that is null. You can do something like this. You can say select everything from null where name is null. Yeah, it works like that. So you can do it like this, and this would extract that particular column that is null. So we get null. Alright, so that's how the null value works. So it allows us to, it tells us that a particular cell in the table doesn't have any value. So let's look at joins. So the real reason why we created these two tables was for us to be able to extract values from each of them. We created it so that we can be able to extract values from both of them. So joins, just as the name implies, it signifies that we are combining two or more tables together. But for simplicity's sake, we're going to start with two tables. So I created the first and second table. So now we have different types of joins. So now let's say we're trying to extract data that both tables have in common alone. For example, now I'm trying to extract chemistry, that is these two rows from this table, based on this column, course and subject. So now the first topic under joins is inner join. So inner join, this allows us to combine two tables together based on shared values, or based on values that are similar with each other. So the query for us to carry out inner join, I'll just write inner join. So inner join. So I'll just come here and say select asterisk from. So from, you specify the table. Now inner join. So I can decide to either make either this my table, the first table, or this one the second, or this one the first table. But because I specify the name here, let's just stick to that. So let's make this table the first table and this one the second table. So I'll say select asterisk from first T. Now one thing in SQL is that it doesn't matter, provided you have not yet written your semicolon, your query does not end until you write your semicolon. So even if I go to the next line like this, it doesn't mean anything, it doesn't matter, provided I haven't put my semicolon. So I will just say inner join. So inner join second table. So now this select asterisk from simply means all the columns from first table and all the columns from the second table. That's what it means. So select asterisk from first, inner join second. So this asterisk also affects this second table. Then you now write your on statement. So now the on statement allows us to specify what column are we trying to join these two tables together by. So which column are we trying to use to be able to combine these two tables together. So the two columns I'm trying to use here are my course and my subject column. You come here, if a course is equal to subjects, very straightforward. So now this would allow us to combine those two tables together based on those values that they share that are similar in that column. And you can see that it's only one value they share, which is chemistry. The rest are not similar. So the rest are not similar. Alright, so you execute this query and you will discover that it will print out only one row for us. You can see we get only one row selecting all the columns from both tables. You can see that this selects serial number, name, course, score, from the very first table and serial number name subject to result from the second table based on that value they share in common, course subject. So you can see it here whereby my course from my first table is equal to the subject in my second table. So it's going to look for values. It's going to look for values under the first table that are similar to values in my second table under subject. Alright, so it's just that straightforward. So now the next thing that we want to look at here is the left join. So what does the left join do? Now, I already said my first table, my second table. So now the left join allows us to extract everything from the first table and only the values that both tables share in common. So this would extract all the rows from this table and just only one, that is just only the row that has a similar value to one of the columns in this table. In this case, it's going to be subject and course, that's chemistry. So this would allow me to extract everything from my first table. That's all the rows, will have all the rows lined up here, and this would only extract just this row from this table because that's what they both have in common, while the other rows will be null. We're going to have null for the other rows. So how do we do that? So you just come down here and you just, this one is going to be left join. You just say select asterisk from first table left join second table on course is equal to subject. So it's this left join that allows us to carry that out. You put your semicolon and then you execute your query. You discover that it prints out everything from my first table and only what it shares in common with the second table. Yeah, so this would be displayed on a Venn diagram. This can be displayed on a Venn diagram. That's just what left join means. Then the next thing that we are going to be looking at is the right join. So the right join is just the opposite of the left join. It allows us to print out all the rows from this second table and the value that we have in common on our first table, whereby the other rows will be null. Alright, so we'll do that. Come here, write your right join. You see, select asterisk from first table right join right join second table on course subject. You highlight it and get the result. You select everything from that my second table and only matches it with values from that they share in common. Now we can do the inverse of the left join and right join. So I call it left join inverse. What does this mean? So now this allows us to be able to select only values from this first table. We are going to be combining them together, but it would allow us to combine values from the first table alone, and it's not going to join it with any value that both the first table and second table share in common. So it only selects all the values from this table except for the value that both of them share in common. So what this will do is that this will select all the rows that this table has that this table does not have. Yeah, so that's what it's going to do. So you can just copy your left join. And then you just paste it here. So I'll show you the difference. So now you can just come here and write a condition. You now say where. So now at that point, when you select everything from this table, you can remember from the previous one we did, we select everything from this table. We're only going to have chemistry, a row of chemistry matching with this row of chemistry, and the other values would be null. So in order for us to get those values here that are not here, we have to specify the values that were null here. So those values that were null here, we know that they don't exist in this table here. So now this would end up only printing out all those values that we had in our first table that we did not have in this table. Because at that point in time, when we had values from this table, the corresponding values that were here that were not here were reading null here. So you can either specify where serial number, name, subject, or result is null. So I will just use where name is null. And if I should run this command again, you will discover that this will print out all the values from my first table that are not here. So you would not see this row here that had Gregory, chemistry, and 82. Alright, so now both of them both have null. Sorry, they both have the name column. So I'm going to address this. This is what we now refer. This is what we can use an alias of our table. So if you can remember in our earlier tutorial, we said alias is a name used in place of the original name. So it's saying name is ambiguous here because name belongs to both tables. We can find the name column in both tables. So to specify the exact name we are talking about, we can use aliases for either of our tables here. I can come here and create an alias of F, and I can also come here and create an alias of S. So I can come here and say where S dot name is null. So what I'm simply doing here is that I'm specifying that I'm talking about the name in my second table. That is, the values of name are null. Where they are null, I want to print out the values from this my first table. So if you highlight it back, you will discover that it will print out everything from the first table that are not inside my second table, and that would exclude the row that has chemistry in it. If you press play, you discover that it prints out all the rows from this table. But you notice that the chemistry row is missing because at that point where we had chemistry, the value also corresponded with the chemistry under subject here. So that's why it's called the left join inverse. So we can also do the right join inverse as well. So for the right join inverse, you want to come here and select everything from right join and paste it here. V. And just come here and just say where. So you also want to specify aliases here as well, F and S. You can just come here and say where F dot name. So mind you, you can use serial number, course, or score, whichever one. Let me just use score. So it's not a must use name. So where's score is. So since I'm talking about where score is null. So this will print out everything from my right table that are not here in my left table. You highlight it, you execute your query. You'll see that it prints out everything that are here in my right table that are not here. Right, so let's look at the full join. So the full join allows us to combine everything from both tables, whether they exist in each order or not. So it just allows us to extract all the values from both tables, both values that are common to both tables and values that are not common. both tables. To select everything from first T full join second T on course equal to subject. This allows to combine both of them. So you can see that it combines everything from both tables, both what they have in common and what they don't have in common. So it doesn't matter. But you notice that it prints out everything from the first table first. Why? Because it's the first table. And the second table follows suit. So you can see that it's only this part, chemistry, that corresponds with this part. And this one also has its own values as well. Alright. So, how do we get the inverse of the full join? Let's see. Full join inverse. You just highlight everything and you can now, so you have to specify both of them. We specify both of them. So you now come here and say where. So now if you can remember, I said you use and when we are looking at multiple columns that correspond at the exact same line. So you can see that I can't come here and say where course is null and subject is null, because where course is null here, subject is not null. So I would have to use or, because or allows us to select based on multiple rules. So this rule and this rule. I can come here and say where course is null or subject is null. So what's going to happen is that it's going to extract values from both tables and it's going to extract values that they don't have in common alone. It's going to extract values that both of them don't have in common. So it's going to extract these values apart from this one they have in common. That's why I said where course is null. So it's going to look for where course is null, which are all these rules here, or where subject is null, we look for all these rules here. So this allows me to extract values that are not common to this table, and this also allows me to extract values that are not common to this table as well. So if you highlight it, you get your results. Alright, so you can see that has removed the value that they both shared in common. Alright, so that brings us to the end of this particular tutorial session. So till we meet again, have a very good evening. So just to note here, the full join is the same thing as the full outer join. So you can decide to write it here or you can decide to leave it out. It will give you the same result. Get the same result. Alright, so till next time, have a very good day.